Yeah. Thanks, Kuldeep, for agreeing to come here in the Thought Leadership webcast. And it is a great honor to have you here. And let me give a brief introduction of Kuldeep because he has managed his time on a Saturday morning when we are all busy with our family. So let me introduce Kuldeep first. Kuldeep is currently heading the data science division of High Labs, a company solving healthcare problems via machine learning. He has nearly 18 years of experience in various industry verticals like healthcare, telecom, financial, trading tools, banking payments, performance tools for e-commerce industry. He has been an entrepreneur, a performance specialist, a big data architect, and a data science researcher. He has led the successful acquisition of a startup by Oracle via technological innovations. So he has also managed performance tuning many big data stacks to bring BOM costs to nearly one fourth of the original. He has published research papers and patents in the field of machine learning to create some complex unsupervised ML models that can run at telco scale. So it's all up to you now, Kuldeep. Your journey, people are willing to watch you, ask you questions. So please share some of the insights in the healthcare industry.
Thank you, Shamishna, for having me on this platform. Uh, Honored to be here and great to interact with so many people. So, as Shamishna told, so I guess, yeah, I have been into multiple domains. My main aim is to actually do some real world analytics so that we apply some machine learning and maybe some ways to solve real problem. That's why I've been in like different domains all along my career to solve something real. And now, I guess, with my current stint in High Labs, I'm focusing on the healthcare domain, where basically the AI can help to ensure that the people get good healthcare to all of them. And so AI with the complex things and other analysis can ensure everybody gets a fair treatment and everybody basically gets a basic care without any hurdles. So that's where the core idea is good healthcare for everyone and how AI can help in that. So thank you,
Yeah,
Samishna. Yeah,
yeah. Some of the use cases or what's the healthcare ecosystem and how it works, if you can enlighten our viewers.
sure. So thanks, Samishna. So yeah, I'll just quickly describe this ecosystem. So generally, this has been quite prevalent in most of the developed countries, like for example, USA, Europe, majority of them. They have the system all along for many years, and it's quite matured over there. So, like in general, any government want to ensure good quality healthcare for the citizens. So, but there are ways to ensure that. One is basically you can force doctors to go to these areas, do these things, and do that. You can control, regulate everything. But generally, things like regulations control kind to demotivate the doctors, for example, and other healthcare workers. So that's why generally forcing is not a good way. And kind of an open system ensures everybody is working with their motivation and passion. So even for doctors and all the healthcare workers, so if they're actually aptly compensated for their hard work, they'll be also happy to do those things. So that's why the thing started that it can't be controlled; it has to be open. And then definitely there are different dynamics over there. Like there could be different motivations. Like for example, different doctors, different skill sets. Some are more complex, some are simpler. So they should be aptly compensated for their hard work. So they want to look that for the motivation. So to ensure all this is works kind of in a more automated way, the government level systems work automatically. As in like the dynamics get controlled by let's say in an open market, and there are some kind of intermediaries in between which can kind of play a controlling role. So when I say intermediary, it could be like a large body in between. Most likely, in most of the companies, these are being now outsourced to like private companies, like insurance companies. So they can play like the role of intermediary, which will kind of balance in some kind of ensuring people get care and also ensuring that the doctors providers are kind of happy and they get aptly compensated for their hard work. So all people are kind of happy and it's like a win-win scenario for everyone and everybody gets the best of thing. So this is kind of like an all good scenario for everyone. And that's where I guess they need to maintain these right economics. So intermediary in some countries also are governments. They also play the role of that in some cases for some special segments of people. But generally, it's left to the insurance companies. So now these companies kind of they want to build the right economics that works automatically in an automated fashion. Everybody's happy and everybody gets the right healthcare. That's the ultimate idea. So what they did to build a system like that, they analyzed the healthcare needs of the entire population and kind of see that these is kind of financially viable for everyone, and also it's affordable for the people to get the healthcare, and doctors also are happy in that. So to make that system, and also they want to make sure it's unbiased. Like for example, some people are sick, then definitely they should also get the same insurance as healthy people, right? If the system biases for the sick people, they definitely get cornered out. So it should be the other way around. They need more care. So to have that moral thing also going, so these intermediaries play a role to ensure the moral value is maintained and also the financial value is maintained. So via all these things, they can maintain these things. So I'll take like one example how like statistics can help in these things. So for a simple thing, like as we know, to ensure everybody gets healthcare, somebody needs to pay the cost. So but who will pay that? And somebody needs to bear the cost. So one way could be the intermediaries kind of pool a people, something called a risk pooling. That means there is a risk of some people, but there is lesser risk for other people. What about pooling them in a bigger pool and share the risk across a population, right? So I'll give a simple example to explain this very simple idea. So very simple thing, like a normal person who is like gets sick once or twice in a year, something like that, needs like $100 healthcare need, right, for a certain period of time. And maybe some people are sick, they need like $10,000 of care, like for a year, something like that. So that's like two different sets of people. They have different needs. So, but we want insurance or I guess care for all of them equally without any bias. So if you just look at the bigger picture, so like 1,000 people have $100 cost, like $100,000. Then 10 people also have individual cost of $10,000. That's again total of 100,000. So let's say both of these groups requires $100,000 each. So total of $200,000. If you divide equally among 1,000 people, you get $200 cost per person. So that way somebody pays a premium of $200. So that means we are covering a population with both kind of peoples, which are healthy as well as. So this is one simple example. There are many more complex examples of different risk profiles. Like some people get extreme disease like cancer, all those things. That's even more costly. They go to like $1 million. So how do they can kind of do a risk adjustment? So that's what these intermediaries do. So that would be like a way of combining the healthcare delivery with the financial objectives. So it's like making a balance between people get the care, but financially things are all okay. So that's where the data comes in. And I guess there also, I was talking about the companies, even the government have some special programs. I'll talk about the uses specifically because like I as part of High Labs is working for the USA region. So over there, let's say government has two simple programs like Medicare program for people which are above age of 65. They provide all kind of healthcare needs to them. They pay for all their bills in simple, as short of that. Second, there's something called a Medicaid program. That's like for people with below a certain income level. So they kind of help all those people to get the right healthcare. So, but just imagine how all this could have been possible via an autonomous system was because of data. So, because the data was electronic, it was in data records, it was all possible. So, like it's more than like 20 years in countries like maybe USA, Europe, where everything is now digital. For example, there is things called an EHR, electronic health record. So, for every person, you visit a doctor, visit a hospital, buy some drug, anything, there is a record for that. Even every doctors they prescribe anything, they need to maybe enter into the system and goes to like a central place. So because of this EHR, data was available and analytics was possible, and that's where the entire ecosystem of this healthcare analytics came up. And actually it was not just this data. The government bodies, insurance bodies did lots of research to understand what is the different needs of people and kind of how could they differentiate. For example, some disease are complex, like maybe heart attacks, very complex things as compared to like maybe diabetes, right? It's less severe, so they require different efforts. So to also kind of understand like what is the effort or complexity to resolve a disease, like so that the doctors can put the right effort and they also can be recognized or compensated aptly. So they did research and made a lot of these things into codes, I would say. So like over there, everything is there's a code for everything. Like for a procedure you do, a doctor does, there's a code. A doctor does a surgery, there is a code for that. There is a particular type of disease, there is a code for that. There is some particular type of diagnosis done, there is a code for that. So for anything you could do, there is a code. So there is a mapping maintained by them that everything could be converted to a one code number. So that coding helps in basically digitally monitoring everything across, let's say, the entire population and their bodies. For example, like something like ICD, like International Classification of Diseases. These are like set of codes to classify all diseases into some number, uniquely identified number with their properties. So medically, there's a clear dictionary that yeah, this disease means this code, and it's been developed by lots of researchers over a span of many years. Then they also have codes for diagnosis, like how you treat a disease. So everything have kind of coded into some kind of objective way, so you can objectively measure things, right? And then but you also know sometimes things are complex because healthcare is more like a personal thing. uh, uh,
Kuldeep, sorry to interrupt. Can you move a little bit right hand side? Your portion is getting cut. That looks good. Yeah, go ahead. Go
so
ahead.
so thank
Hmm.
you.
Yeah.
So I was just explaining that how can they make sure that all procedures or surgeries are understood in the right way. For example, surgeries are very complex, require sort of risk expertise. So we require high skilled surgeons like doing an open heart surgery. That's a very risky thing. So we require skilled doctors. But as compared to that treating something like diabetes, we require different skill set. So that's where they again did studies and made something like a list of DRG codes. That's like diagnosis related groups, where they can group these similar kind of effort disease into groups which are require more effort. Complex ones are separate apart, simpler apart, some longer ones are apart. So in short, this I would say was a short summary of healthcare system where actually because of digitalization, everything was coded and came up with in a structured format. And because of the research, they also kind of studied these different subjective things and also tried to codify them. So now I guess we have a system in most of the countries where you can use these codes to I guess label everything and record everything, your entire history, your life history over these codes. So
Yeah.
in short, this
Kuldeep,
was the
so
story.
there is a question from Harini Anand. How
Hmm.
has the current pandemic changed the direction in which AI applications are being developed? Do you want to take it up?
Sure, I'll do a quick one. So definitely, this pandemic required new things. So as you know, like as this is the entire objective of healthcare is to ensure we people get the right care. So they don't want anybody to come with the quickly a new drug and just release that. Like pandemic was a great crisis, so everyone want to come with a drug and sell that quickly, right? So there was a risk somebody may come up with a fake drug and actually release it quickly to gain, I guess, lots of revenue. So that's why they had this standard body. So they had the trials, phase one, phase two, phase three. There's a detailed list of things. I won't go into detail of that. But they ensured that actually these things conform to still the standards and people get the right thing. So did pandemic, yeah, raise opportunity for that. But because of the healthcare ecosystem, the system in place, although it took a little bit of time to get the right vaccines, all those things, but they ensured there is some objective way of measuring them. There is no subjective and like a rush for them. So in short, yes, there was opportunity and was rightly taken care of.
Yeah. So the next, can you highlight us what are the dynamics? Yeah, I think you have already highlighted some of the dynamics, but mostly the challenges that govern the healthcare industry, mostly related to technological innovations and the practices that we are following for the different standards and all.
Sure, that's a good question. I think because with everything kind of working in autonomous way, there are also other problems comes in life. There are pros, there's cons, right? So every things has a two sides. Every coin is a flip side. So although this ensured everything goes digital, people can be tracked, their healthcare is tracked, they get the right care. Objectively, we can define the doctor is not biased, all those things. But freedom and independence comes with responsibility, and definitely some people can misuse responsibility. Like for example, I'll take a few example. As you know, like the doctors know that somebody else going to pay for this cost, let's say surgery, like insurance company is going to pay for that, right? The person is going to pay. So maybe they know that it's a large body, like maybe government is paying or big companies paying. So there's a possibility, I would say a very small segment that could happen, that they do lot many extra procedures or extra things not required. For example, they treat or do some 50 number of tests. They do something like I would say extra surgery that was not required, right? Maybe it could treat by a medicine, but it is surgery. So this also possibility that to get more money, they could do things extra. There may not be any harm, but still it's kind of not good, right? So people could has to go through extra things just to get more money. So that's, I would say, is also a drawback of an open system. where things are controlled, right? So that's, I would say, is one drawback that needs to monitor. So insurance companies and government need to ensure this does not happen, right? So I'll take a very classical case that probably happened recently in USA. Uh, Doctors, like people were going to doctors for a back pain. So back pain, as you know, is a very common thing. Generally, people in their 30s, 40s, they get back pains often, and they go to doctors. So what doctors were recommending, without just looking anything, just go for MRI scan. And as you know, MRI scan is pretty costly. Even back in the US also, it was in multiple thousands of dollars. So that's a very expensive scan, expensive technology. So they were recommending everything, buddy, for MRI because the companies were paying for MRI. So people didn't care. They said okay, but actually there was a drawback. Majority of the back pain are simple things like a simple therapy, maybe like a few exercises could resolve that. Yeah. So that's why they realized that this is not correct. So that's where these intermediaries like insurance companies or things they came in and they said you need to take an approval for that doing a MRI scan. And we look at your history. If you don't have any chronical history of any severe back problem, you don't need a MRI scan. Just go to a therapist and go out for treatment over there. So they kind of actually directed the people to do a simpler thing first, then do a complex thing, right? So this was like one way to solve a challenge. This was a real practical case. So like MRI for back pain, and 80% back pains are kind of regular due to lifestyle. They're not diseases, right? People get aged out, and that's why they have some issues. So they just need to get healthy back again. So this was one problem. So there is another side because companies can pay doctors, let's say, for case basis, but it's also possible that the insurance companies pays the hospital like a lump sum. Like this is the amount you're going to get for the entire this procedure and just solve it. This other side risk could be that maybe doctor knows the amount is fixed. He knows what he's going to get. So maybe he don't give much care to the patient. He knows the amount he's going to get. He's done with that. So he'll do basic things and just leave the patient or don't get too much care. The patient gets less care of that. That's another challenge, right? So of undercare. So one could be earlier talked about maybe the overuse of things. Other could be underuse of things because he's already getting money. He don't care about that, right? So these finances can also affect the healthcare or treatment of people, right? So we need to take care of those things. And I'll take care of another extreme case, something called as the upcoding. Like as I told you, now everything is terms of codes. So possibly, like for example, somebody's getting treated for diabetes. So he'll charge the patient via setting these codes in his report. He'll get the money based on the codes. But maybe while writing the codes, he writes a code for type 2 diabetes, right? That's more complex, severe form of diabetes. And definitely, as no it's a complex procedure, they'll get more money for that. So they can do upcoding. That's called thing, kind of a fraud, I would say. That's a possibility. So although people get the same kind of treatment, but the providers or doctors are charging more. So that's again a misuse. So these are like challenges, I would say, all different kinds of things to ensure we build right healthcare and the financially they are okay. So we need to prevent this. So these are like some of the challenges I would say. Yeah.
Yeah, so this coming to know about the challenges and the misuse of the services, right? So how can we apply AIML to improve the system overall? And I think there are two more questions we will go as by Vijay. So can you please highlight on the AIML perspective, then we will go into different statistics or some of the data sanity issues the questions are asked related to those areas.
Sure, definitely. Yeah. I think I'll come to that. So that's why basically we need analytics, AI, ML to basically solve these challenges, right? So for example, I was telling you when somebody submits a claims, right? So that claim has information that what he was treated for, what diagnoses were done. So there are like codes for everything. There was a diagnosis code, there was a treatment code, there was like a drug given to him, codes for them. So any surgery was done, there were codes for them. So basically, all that comes in the claims data. So now, because let's say somebody who's like a large body, like an insurance company or a government, have data from lots of people, like a big population chunk. So this is where AML can understand that looking at the population, it can find patterns. And just to do before you go to the AML, in general, the human body is complex, right? For example, if some disease happen, some other also happen. For example, let's talk about like diabetes. Somebody has diabetes, it will also affect maybe his blood pressure, also affect like hypertension, right? So generally, body kind of shows impacts in many ways. So we can quickly understand this from data. So, like, so for example, looking at code, somebody was treated for diabetes, was also treated for hypertension, or treated for blood pressure, right? So we can catch these patterns from data. And if you let's say a large population, so let's say from majority of them, we can see for this type 2 diabetes, these other things were also treated, and we can build a model which can learn these correlations, right? These interactions, and maybe save them in model history. Now, let's say new patient comes in and we get a claim for that. So we can kind of test it against those historical correlations against population. For example, he has a type 2 diabetes code, but he does not have a treatment of hypertension, not blood pressure, not something. So that shows kind of alarming sign. Like let's say 98% of people, there's a statistics, yeah, it's not 100% always. That's where the probability comes in. There's a 90% chance that he should have got a blood pressure, right? But he has no such codes for the other things. That means there's some mismatch. So like we can find and flag these things, like we call it like anomalies, right? So this is like one based on mathematical correlations. We can find these patterns and find the different things. That's like one way of things. Then I guess there's other ways. You can also infer these codes done based on other data. For example, people also get some tests done in the hospital, like lab tests and other things, blood tests they're doing. So they also gives indications of the state of the body. And definitely, if somebody has a high blood pressure, his index for that will go up, right? So that numbers will go up. So those numbers, the data could be used again to find mathematical models to say if this index goes above these things, then you have this kind of disease or this kind of problem, right? So and because most of the humans behave in similar way, so we can build mathematical models, AI models to analyze again. I would say the medical charts, lab test reports to build these things. So in general, I would say AI ML can understand how the I guess high level objective dynamics of the body works and kind of connect them and use that to find anomalies, misuse, abuse, all those things. That would be a quick summary. Yeah.
So, for this question, Kuldeep, how do you see the difference in applying statistics or hypothesis to drive decisions in AI model to decide the same in healthcare? So, do you want to highlight anything on the specifically on the fairness point of view, or any specific models based on your experience, which we should
Exactly.
be very much concerned about? Yeah.
So I think that's where that's the right question. Statistics play an important role because, as I say, it's not always 100%, right? For example, as I take an example, with type 2 diabetes, you get hypertension and blood pressure. That is not 100%, right? There's a probability. So in data science, you talk about probabilistic things. There is no thing certain. So that's where we build a hypothesis. Like for example, I build a hypothesis that given there is a type 2 diabetes, I expect to have a hypertension code. So like code of hypertension should come with that. So the probability for that should be significant. So I'll make a null hypothesis that will say there is no blood pressure code given, let's say, my type 2 diabetes code. So I'll find the condition probability for that. So I'll make a probability distribution of these from data and find the p-value. So again, we do some hypothesis testing, and if the p-value is below some certain value, we can say, yeah, this is significant or significant. So yes, statistics comes to real play. So that's why we need to be very cognizant of the fact what we are measuring and is it significant or significant? Because this could also possibly also noise could come in, right? I was talking a few examples. There could be some weak correlations also, right? Like for example, maybe like a fever coming with diabetes, very rare case, right? So, but that may be correlation, maybe by coincidence, right? So that's a possibility. So that's why these statistical significance comes into play, and we kind of use this to differentiate between the significant ones and less significant ones. So that's all the hard work of data sciences. Data scientists basically comes into play.
Yeah. Thank you for answering these questions. And I think there is another question from the Vijay also. This is the inadequate data and data usage restrictions. Sometimes we have feature loss during sanitization. So, what is your view on that?
So basically, he's saying inadequate data or decision data. I
Correct,
think,
correct.
yeah. So to me, I think probably he's referring to some kind of public sources. So depending on how you're working, so definitely if you're working in public domain, it's hard to get it because actually this is like PA data. So it's personal information data, or in actually it's called PHI, personal health information. So in US, there's a term for this, or in many of the countries. So where the data is classified, you can't have a look at this data. So, but that's where you need to be right place. For example, you're working with an insurance company, so that's where they get the data to actually kind of see the claim side or not, right? And because they want to judge system is used fairly, they can ask for additional data. Although they don't need lab tests, right? For example, insurance company doesn't care about the lab tests or the other tests, blood tests done by the people, but they can still ask for the clinical data. Let's also do send us clinical data. We want to ensure or do some kind of analysis before we approve the claim. So I would say if you're working at the right place, for example, with the either hospital level, so hospital will have data for the hospital. For example, all the patient data in the hospital will be having a central record for them. So that's where you get data sources. So in short, you have to work with the right people, and this is not public data, so it's not available publicly. So when you're working with those systems, let's say working for a company, for a healthcare body or insurance company, so they will provide you data and with the all those PHA nuances. So you need to be compliant with those and then treat. But you comply with all those things, then I guess you have ample data if you're in the right place. So data is not an issue. Yeah.
Yeah, thank you for answering. I think Vijay, your question is now answered. So, if even there are inadequate data, how we can handle those in our systems? We should be more robust and have those resilient measures built in, so that we can our probability can actually predict that how much confidence we are predicting the diseases. Uh,
So definitely. Yeah, so that's a good question. I'll now come from the more Aiml perspective. So that's a generally data science question. So that's where I
mhm.
would say we call the sample bias. So that's a good question. So if we have a smaller sample and then probably you make inference on that, it may be biased. Like for example, so that's why we need to do more techniques. Let's say we do build multiple samples. So I think there is a very important concept of data science called the central limit theorem. So, for example, a very simple thing, you're finding, let's say, the mean of something, the central value. So, the best way, if you, one way is look at the entire population, find the mean of that, like the height of the entire population. But we can't look at the population because there's so much of data and we can't even get access to all of them. So, best way is take random samples and take multiple random samples. So, let's say the mean of one sample was something mu1, sample 2 was mu2, then sample 3 was mu3. Take the mean of these means and ensure these samples are random, like IID. So independent data, they were basically independent samples. So then you can get to central value. So yes, if you have lesser data, take more of random sampling approach and take kind of a central theme of that or the expected value. So this is more like a data science theory. How do you formulate a random variable? What's the expected value of random variable? And then you kind of find the error in that. So then definitely every number statistics come with some kind of error, like a variance. So you also know what you're measuring, how much does that vary. So those statistics, like second order moment, like variance, all those things, along with expected value, combines tell you how good that number is. Is it stable? Is it varying? So mathematically, yeah, data scientist's job is to basically ensure that we don't get bias by a specific sample, and the results are kind of statistically significant.
I hope that answers our question again, Vijay. And coming into the tech stack, Kulip, so what would you the most recommended tech stack for AI in healthcare? Means, of course, it will depend on kind of problem we are solving, but from your experiences, what becomes the most important?
Yeah. So I guess again, as I said, most of the healthcare problems can be solved if you have adequate data. That means the statistics are right and you're not biased by samples. So you need a large data to come at right conclusion. So that's why ideally, if you're working with a large body which have amount, for example, bodies in US insurance companies, they treat, I would say, millions of people across USA, right? So then you get data for millions of people. So that's where the data records, like when you do visit a doctor, that's a record for that. And then you basically buy a medicine, go a treatment, go a therapy, you get record for everything. There's each of everything. There's large amount of data, mammoth amount of data. So for that, definitely you need a big data stack. So that's the first and foremost thing. That how you can pre-process data and basically convert them into, I would say, statistical features. So the first part is we call it like feature engineering in data science. So or in a simple way, converting data to information. So you get a large amount of data and how you can represent them concisely in important things. So what you can extract from them, right? So that's, I would say, very important part. So in tech stack, so definitely you first need kind of big generation tools, processing tools, like for example, like Spark, Hadoop system, all those things, distributed architectures. So you can't do a single machines. So you like mostly need a cloud architecture where you can do this processing on the cloud. So you have these clusters, distributed clusters on the cloud where the data is present and at times it is proprietary. So these companies may have their own private clusters, their own private clouds. So depending on whatever the scenario is, you need to first process into a big data stack. They need to have these, I would say, most likely the ML stack. That could be maybe if you could reduce to significant amount, you can maybe first analyze into your Jupyter notebooks, look at trends, do some EDA, the expert data analysis, and understand what's the key information over there. And once you have analyzed data, find the key things. Then I would say you can go back to big data technology and create some pipelines. So analysis, I would say you should do on a Jupyter notebook, understand the data properties, maybe look at some few random samples, and then see what's happening, what's the trend, how you can find the correlations, and then go back and apply these rules at big scale. For example, correlation rules. So you can make a big data engine to find correlations at a large volume data. So you got the idea from these samples that you want to do, then you apply it on a big scale. So it's a mixture, I would say, the data science tools, maybe at notebook level, at other complex libraries. There are many things we do. Like for example, we have different information coming in, we do some analysis. So we need complex signal processing libraries. All this can be done by in a smaller space, but need to apply them in a big scale. So ML plus big data would be the right stack. And then I guess we need to ensure all there is also compliance, like there's HIPAA compliance, all those things need to maintain. So data has to be secured. There needs to be kind of conform to lots of these things. So there are also these regulatory things around the data. So you need to have a stack for processing, stack for regulation, a stack for basically the machine learning things. Then you need like I would say very precise kind of computation resources to ML things. So you need all compute power, this thing. So it's a mix of, I would say, all these things. And with now people moving to cloud, it's getting easier because they understand these needs and they can create these instances beforehand for, let's say, the healthcare domain, other domains. So that I would say would be a short thing. Yeah.
Thank you so much. Thank you for making us understand how end to end coming the data ingestion, the machine learning, the regulations stitched together. So, how is your experience, or how High Labs is different, or what they are doing? If you want to highlight some part of it.
So I guess definitely I was also really enthralled to join this group, and I was also new to healthcare. So I realized this is an interesting area, and we have not matured enough on AI part over here. So there's lots of scope over here, and especially there's lots of data, and but there are also challenges. So because with a lot of data, you need to go to like unsupervised techniques, unsupervised machine techniques. That's complex, and that's also kind of give you new avenues to do innovations, research. So that's also motivated me, and I guess so in High Labs, we have done these things pretty well. That first is the innovation part, find the right things. So we have some great, I would say, SMEs who understand the business domain pretty well. And to me, you can solve a problem not with data science, but by applied data science, because you can learn a lot of theoretical things, but theory and real world differ, right? So there is, if you just search on Google for data science Venn diagram, there are popular Venn diagrams. So in a general theory, data science is like three things to me. One third is actually ML. So machine learning is just one third part of that. One third is business, what we do ML for. One third is engineering. How do we solve that, right? So we have done all three here at High Labs. Like we have great domain experts who have been in healthcare for like decades, and they understand how healthcare works, what's the nuances of this, what's the risk, all things, how data can vary, what could be the pitfalls in data, all those things. So based on that business domain knowledge, we started a focused approach. Let's solve this problem. Like for example, talking about upcoding. Let's solve for target that. So what all things will you take care of upcoding? So we need to process claims data, clinical data. So that came from right. So so it's to me it's like a top-down approach. Start from the business. What do you need to solve? Expand that to the analytics. To solve this business problem, what kind of machining should I do? Like for example, to solve this problem of coding, I need to do correlations, pattern mining, right? So that was came to the machining level. But what kind of pattern mining? All those things. So these are different things we need to analyze. So that's the second level. Then once we identified the technique, how to implement that? Like the data is used, you can't do it in no time. That's not possible, right? So we kind of did all of that, and eventually after doing processing, you need to present in a way that's understandable by the user, right? So it started with these business SMEs. They formulated the problem in the right, precise way. Then the data scientists, they found or researched the kind of algorithms which can find these correlations patterns. And then they found scalable versions of those to apply at big data. So we use tech stacks like Spark, all those things to process data in a more format that's usable. Then we use things like, let's say, Solar to pre-index these things. So because we can't do everything at the processing time, we need to be quick over there. Like a new record comes in, something like a new event comes in, so we can handle it quickly. So we want this all to be pre-processed and available for analysis. So we use like large-scale indexing via things like Solar, which can use convert these learnings into rules. And when these comes, apply rules quickly. So that makes like a real-time system, creates like analytics dashboards for the users, for the companies to kind of summarize. So in short, it's an end-to-end story from I would say business knowledge to machine learning to big data engineering to basically smart I guess say UI building that can efficiently handle big data queries and also represent in a good concise way. So that will solve this problem. So to me, this entire journey has been done over here, and that's why these guys are doing pretty well over there, and we hopefully we solve much more cases.
Yeah, I can't agree more. Taking the business problem is the most important thing. Like, how do we look at the business and side of it? What problem exactly we need to solve? Then narrowing down to the engineering. Like, because only machine learning is nothing. Like, it's just a model. But how do we teach and make it user-driven system? How users or stakeholders can understand what we are trying to communicate. So that's the entire story behind using AI in a particular domain. So, Kuldeep, my question one before we go to the future trends and all, my question is: you have talked about so many things, the technical aspect, big data, ML, business, but if, in order to make there are different entities involved, right? The providers, the patient, healthcare hospital, researchers, like something like a federated system when we use. So how can we bring them and collaborate them so that we can get as much as information as possible and make our machine learning models more accurate? Because I understand there is we have to collaborate, or we have to agree that people would share data, because healthcare is a very private oriented domain.
Yeah.
So is there anything the industry is thinking about, or we can do something?
I think, yeah. So as I said, the key problem is it's private data, right? So definitely nobody can make it public until it's people allow them, right? So one thing is, if like for research purposes, people by themselves they kind of want to donate their data, right? That's one thing. So some people volunteer to say, yeah, for the benefit of research and benefit of basically new innovations. So we donate for something. That's why we have bodies, let's say like bodies like Kaggle. So they can at times maybe they mask the PHA data or the PI data, I would say, and then make sure that without the PI data, without any prior information, we can still share the data and let people do analytics. So that's possible. For example, we can remove the name, the address, all those things, replaced by some unique numbers like hash code. So there are techniques people use to mask the PI into hash code, so we can identify still the things and maybe confirm that this case was for this particular patient by using the hash code of that. So using these techniques of masking, so people do at times share data in a, I would say, a masked way, where the private part was not shared, but yeah, still the information was available. So people will do this analysis, and then we have these forums like Kaggle to open host challenges. People can work on and build models. So I guess yeah, there are things coming in place, and I guess it's kind of both. People willing to share, and also there are some intelligent bodies which have some data, own the data, and also make them public for research, or they do their own research bodies. So I guess if people think about that, and hopefully we'll have more of these so that we can do more innovations in this area.
Hmm. Yeah, so yeah, if public bodies like Kaggle shares the data, that becomes much easier for us, at least for budding data scientists who are viewing, or people who want to take some challenges and see their data science skills, that will become more efficient. So the most important thing is how where is the industry heading? So what are the use cases that we as learners can look into, or we can contribute, or industries as such can also look into, to bring patient's life at ease or doctor's life at ease?
Yeah. So I think yeah, it's a both way thing. So probably we want to make the lives of doctors easy so that they are free, they feel happy, their hard work they're doing, they get that compensation, so they are easy. Then also the patients getting right care. So so that's why maybe in general things are always good. But there are only a few cases, like in the haystack. So that's where I guess one AIML can come in. They're finding those anomalies. So maybe out of those million records, three were like misuse, were fraud, abuse. This that's why they have this word like fraud, waste, and abuse. There's a concept over there to find the FWA. So how to find fraud, find waste? That's possible. The intention was not wrong, but because it's available there, for example, in hospital, they have so much of stock. They keep using and throwing things, right? Use anything medicines. They just keep throwing that. They're wasting that, right? That's also a thing you want to prevent. So we want to prevent fraud. We want to prevent waste. We want to prevent abuse, basically. Yeah. So we need to find the system. So that's why things like AI, let's say, can find these anomalies, I would say. So one is basically finding that small signal in the data that's different from them. So this anomaly analysis is very key area that is quite relevant in this industry. What is different? Which patient got treated differently was different? Which per did thing that was unusual? So find these anomalous patterns pretty useful. That would be like one way industry is moving right now to find anomalous use cases. And if we can, let's say, solve these anomalies, most likely the few aberrant people or the aberrant providers, aberrant the systems guys, they are kind of cornered off, and the system is not healthy, right? So in short, we ensure the health systems by finding the aberrant people by anomaly detection. That's the one major theme of the system, finding anomalies of various kinds. Then I guess that would like be the reactive case. One could be also doing a proactive or prescriptive, I would say. For example, you go for a health plan. You want to tie up with a doctor, so make a family doctor and visit him too often so that he can track your history, right? So can we like find the right doctor for you? For example, people have different health conditions. Somebody's they affected by diabetes, for example. Somebody's affected by hypertension. Somebody's something else. So maybe from data we could figure out like these doctors are expertise in these areas. Although it's like specialty, but normally doctors have multiple specialties, right? He could have 10 specialties. So maybe, but as per his experience, he has some kind of great, I would say, niche about one particular thing. He can solve it quickly. He can find the essence pretty quickly without too many of tests, everything, without too many of the procedures. So he's pretty good at that. So data can find it out, and maybe I would say kind of a match the right doctor with the right patients. So like I would say the correct attribution. It's like a proactive attribution so that people get to the right person in the most less amount of time. Or also look at logistics. For example, definitely doctor should be in the same locality. He has to go to catch a plane to find the doctor in a different city. That's not possible, right? So maybe in the reachable area, and definitely doctor has an appointment available in the next day or so. So all these real time stuff. Then maybe something like these global stuff. So we can do like these. I would say these kind of a clustering things, these matching. So these are like long manual concepts. There are lots of things, different type of disease, there are disease patterns, based on expertise patterns, based on patient's healthcare data, his history, what he's currently likely to be, what kind of care he would require in future. So I would say all these could be automated and makes things more smarter to predict what's going to happen next and take care of that right now. Like for example, somebody has a stage one cancer. So find the likelihood of having a stage two cancer for them. Maybe how much time? Maybe like 3 months, 6 months. So we can get the care for that person right now, right? Or maybe somebody is likely to get a cancer. Data can catch that. So instead of waiting for him to get a cancer, treat for the cancer, maybe do something right now. So that preventative care. So that's where I would say the care part comes in. So and we need to make sure this is profitable. So that's the way concept comes of like the value-based care. So the care is valuable to the people and also for the providers. And the even the insurance companies prefer this to happen. Like for example, they would prefer the person gets healthcare initially. It's good for the person, good for the company because he'll not get much sick. They'll not have to pay more. It's both financially also good and morally also good. So I would say healthcare or this AI can build all those things. And in short, yeah, provide right care right point of time. So
Yeah.
that
So
yeah,
and of course, some of the diseases, don't you think that are very small section of the population get in say city or among the demographics? Maybe some part of active learning with actual intervention of the doctors, which you were telling, right? They can help to provide some feedbacks, and that gets into the ML model next time while training, so that it is more real time with the interaction between the doctors and the patients and the healthcare system as such as a whole. So
definitely.
definitely, these are wonderful insights. Yeah,
Yeah.
you were
So
telling
that's
something.
what these companies like AIML companies, like for example, companies like us, High Labs. So we also have like a good medical practitioner along with us in the company. He's also co-founder of the company. So he also gives his medical views. So along with the AIML we do, we also have that medical view to ensure things, as you rightly said, can be seen. So based on those things, we can find the things at the right point of time based on medical things also, not just technical data, right? Data can be just statistics. Statistics can also be get biased. I said sample or something for demography. So we for that's possibility. Like in urban areas, we get more data. We get less in rural areas, right? They could have different problem. So the data could say differently for the data. So that could be a bias in data, right? So we can balance that by let's say these SMEs, medical doctors. So we need to have those. So yeah, so that's why we ensure we also have intervention of these actual medical practitioners to kind of say balance between data versus reality.
Yeah, and our life is, don't you think our life is also made easy by managed services like AWS, Google? These cloud providers are already giving some tools to analyze, uh, see the anomalies, detect the anomalies, maybe build the pipelines, or make sure that when we store healthcare data, this HIPAA compliant, as you were telling, right? We have to ensure in based on the individual countries and the regulations we are following, all this are maintained. So our life is also made easier by these cloud providers. So, any other thing you would like to share based on your experience, that I leave it open to you, and where people can learn about it from your experience, or so that they are better in the field handling the problem?
Sure. I guess I will just reiterate the key fact that when you start your career, most likely, I guess data science is not like a study we do in college, right? So it's on the job study. We learn on the job. So I would say the key thing is first to solve the problem. So that's where I would say like an engineering mindset is good. You want to solve something, right? So that's his focus. That brings focus. And then, but there is the other drawback. Everything has an extremity, so we should avoid extremity. For example, if we just work like an engineer, so we use an API. So we are like, for example, we Google about these data science APIs. Like for example, you search sklearn has a model. You can just call the model API, do a call a train, call a fit, do a predict. Right? It's easy. But I guess just using Aiml is also risky. So that's why you need to understand the maths also. So if you're a data scientist, you may not need maths. You don't need calculus, right? Derivatives to actually do that. But you should understand derivatives to understand how did the algorithm work. Like it optimize something. So for example, you're building a model. It's optimizing some cost function. Like for example, it's optimizing something. For example, like in case of predicting a simple time series, it's minimizing the error. What we're predicting was actual things, right? That is minimized. So you understand what is getting minimized. So there is some aberration, some irregular data. So you can see what caused that. So I would say you should have a good maths knowledge also. You may not need to solve maths problems via writing on a paper, but that knowledge is important to use that. You must still use the APIs, still use the codes that ready things, but maybe you need to modify them slightly. For example, real world, the exact model may not work 100%. It may work 90%. So 10% you customize, but you could do maybe it's just a few lines of code. But if you don't understand, you do random things, and maybe that's where you go into problems, and that's where people, I guess, enter them. So I would say you focus on the key thing, and engineering solve the problem first thing. Understand the maths to know what you're doing, and the third most thing is the business problem. What you're trying to solve. You should always go focus what you're solving, because you can just do research. You can find Google, you find lots of papers, right? People write PhD papers, research papers, so they'll do it for their own problem. But if you use their ideas, they solve their own problem by doing some research. But you copy their ideas, so they may not be exactly fitting to your thing. And it's real world. There are no exact things. Everybody's different. Everything scenario is different. So that copy paste things lands in the problem. So that's why I would say stay focused on what your problem is in the company you are working, in the project you are working. What is objective of that project? Backtrace back to the analytical problem, find the right mathematical solution for that, right algorithm for that, and then find the right way to implement. So to me, it should be an applied data science where it's a top-down approach. You start from the top, the business problem, then the machine learning, the maths algorithm for that, then the engineering, how to implement. Do you need scale? Do you need speed? All those things. So different architectures comes into play, and you solve the problem. So end of the day, solve the real problem. That would be my
Yeah, thank you
idea.
so much. Can't agree more. Means I've seen like we try to like modeled outfit. It's not everything. So we need to know the optimization function. If we need to tweak a little bit, if we need to add a constraint, we should be able to do that. So that is how we become a real data scientist rather than taking out the research paper and fully copying it. So simply, I can't agree more. So thank you so much, Kuldeep. So for having you here, and it was a fantastic session. I think the video stays in YouTube, so if you have missed the session, you can feel free to watch, and I'll share in LinkedIn again. And feel free to ask questions if you have not been able to as a part of this session. Thank you so much, Kuldeep. Would love to have you again and share your life experiences in data science, maybe some other domain. Thank you so
Thank you
much.
very much. It was my pleasure. Thank you.